On section 3.7 of the grade 9 academic course called the Distributive Property. And your goal for today is to multiply polynomials in which there might be a bracket. And we actually call that expanding. And you can see that in the vocabulary section down here. This example right here tells you what our goal is. And really it's get rid of brackets. If you have a bracket, how can we get rid of the brackets? And it's called expanding. In the grade 10 course, you'll actually learn to do the opposite, going from something that looks like this, an expanded form, and you make it into what we call a factored form. And factoring is a grade 10 skill. But in grade 9, it's the other way around. You've got to go from something like this, where you have a number or a combination of numbers and letters, like a term. It could be 3a, it could be 3x, it could be 3c, it doesn't matter, 3 something or just 3, multiplied by some bracket. Inside the bracket will be a polynomial, almost every time. Okay, otherwise it's not really worth doing. And you might be able to inspect this and already determine the rule, determine what the distributive property is, but I'm going to explain it to you like you can't. Okay, so this is what we call expanded form, and it's your goal today to be able to do that. Okay, get rid of brackets. So in this example, first one, we call it a distributive property. Okay, that's what I'm asking you to do here, and it just means distribute the 2. Distribute the 2 into the brackets by multiplying each term in the bracket by 2. So there's a 2 outside the bracket. To apply the distributive property, you take every single term inside the bracket and you multiply it by, in this case, 2. Okay, and so 2 times x is just 2x, and 2 times 1 is just 2. This one's nice and easy because it's just a plus sign, and the numbers work out quite nicely. Okay, sometimes they don't. Important skill, I'm just going through some examples to show you the different things you could run into. An important thing to know is that if there is a negative sign, in this case, out front, you have to include that in the multiplying. Okay, so this is minus 3. It's like minus 3 times x, so that's minus 3x. Minus 3 times minus 5 would be a positive 15. So this minus times this minus gives us the positive. 3 times 5 is 15. Okay? Just a little thing that you may or may not remember. If there's no, we usually use the x, like a big X for a multiply sign. If there is no multiply sign written, it's implied that if a combination of letters or numbers are written right beside each other, then with or without brackets that they're multiplied. Okay, bigger examples, same thing though. Okay, we have 3 terms on the inside and 1 number, and all you do is you multiply the 3 by every single term. 3 times 2b squared. So you remember when you just multiply the numbers, you can't do anything with the b squared, it just stays as it is, right? 3 times 4b is 12b, and 3 times negative 5 is negative 15. So the sign, right? The sign stays the same because this is positive. Again, if I'm going too fast, just stop, but I'm moving ahead. Okay, this is a big example. There's a lot involved in it, and maybe 2 things I want to highlight first. One is to remind you, what is this like? What does this mean, right? Expand means get rid of brackets. Simplify means collect like terms. So that's what we're going to do with this expression. And it's really just, I look at this as a math sentence. It's a math sentence. We're going to put it in proper grammar. As you get going, before you do, let's just make this note on the side that when you are getting rid of a bracket, if I ask you to expand and get rid of a bracket, you must multiply the term out front. So the term in this case is it's 2x, and in this case it's negative 3, by each term inside the bracket. And I thought I would give a little numerical example of what I mean, of why that's true. And if it were numbers, and say you had, instead of having, just say we had some number, so 2 times 5 plus 2 inside brackets. Well, the way we would evaluate that is you do the brackets first, right? So that'd be 7. 5 plus 2 is 7. 2 times 7 is 14. And that's how we would evaluate it. You could evaluate it by applying the distributive principle, right? We would never use distributive principle unless you had a variable, a letter in there, but you could and get the same answer where I'd say, okay, 2 times 5 plus 2 times 2, so I'm distributing the 2, right? And 2 times 5 is 10, 2 times 2 is 4, and you get 14. Those are equivalent statements, equivalent methods, just as correct methods of doing the same thing, which I'll just say again, a beautiful thing about mathematics is you can be creative in how you solve a problem, but you still get that sort of comfort or satisfaction of a correct answer. And I love that. And so you can solve these two different ways. I want to show you an incorrect thing, and it's a very common mistake. And maybe I shouldn't highlight common mistakes, but something that sometimes happens is we multiply just the first term. We forget to multiply the second. Someone might do this, 2 times 5, and then just go 2. Well, if you worked that out, you'd have 10 times 2, which is 12. So we know it's not correct, right? But it's a common thing. Like if it's 2 and then it's x plus 2, so replace that 5 with an x. And a common mistake would be to say 2x plus 2 instead of 2x plus 4. But anyway, that's just a little aside, and it was just my little primer for doing this hard question. So I'm going to get rid of the box here just so we can see it. Let's go through how I came up with this solution. And I want you to go with me step by step because this is a tough one. There's signs involved, there's big terms. 2x times x is 2x squared. Okay, that's where I came here. X times x is x squared, and then you just have the 2. 2x times negative 5 is negative 10. So the reason this is negative is because we're multiplying 2x times negative 5. Now, remember with distributive property on this side then, I have minus 3, so it's minus 3 times x squared, which is minus 3x squared. And then minus 3 times plus 2 is minus 6. Okay, so minus 3 times plus 2 gives me this minus. So this is minus because I'm multiplying minus 3 times positive 2. This is minus because I'm multiplying minus 3 times positive x squared. Okay, this next line. So if you get this far, you're in pretty good shape. This next line is just rewriting it with the x squareds beside each other, collecting the terms or grouping the terms. And then I actually subtract, right? 2x squared minus 3x squared. 2 minus 3 is negative 1, which is negative, or I didn't write the 1 there. It's implied though. And minus 10x, that stays the same, and minus 6 stays the same. So that's a good hard question. And if you can work yourself through that without making any little errors, you're in great shape. All right, you ready for the fraction? Let's go. Okay, let's do this. So this is the same question as we had up there, but now there's a fraction. So let's go through how I came up with each term. The first is distributing the 1/2 times 2a. So I put that over here. 1/2 times 2a is, 1 is 2a over 2. I went through examples like that before. And then 2 over 2 cancels, and you end up with just a. Okay? So that's why that a is there. The minus 3, well, 1/2 times negative 6, I have right here, is minus 3. And the reason is it ends up being minus 6 over 2, which is minus 3. Okay? So this minus 3 is there because 1/2 times minus 6 is minus 3. This is a beauty, but just keep following along. Minus 2/3 times 9a. Okay, so I've got minus 2/3 and 9a over here. So that works out to 9 times 2, which is minus 18a. The minus is because of this. And then 9 times 2 is 18, and then the a stays. And I still have 3 at the bottom. Okay? It's kind of, again, it's like I'm saying minus 2/3 times 9a over 1. And then I can go 18 over 3 works out to just minus 6. And my a doesn't change. There's nothing to get rid of. So I just have minus 6a. So that's where this number came from. All right? It's minus 6a because of this. And the last term, plus 4, let's see why that's true. Minus 2/3 times minus 6. A minus times a minus is a positive. So I've got positive. 2 times 6 is 12. And again, there's nothing to multiply, like it's just over 1, 6 over 1. So that just ends up being 3. 12 over 3 works out to 4. 12 divided by 3, which is 4. So that's where that came from. Again, if you can follow that, great work. You're in great shape. And if you can reproduce it on your own, you're in better shape. Anyway, I probably could have written an extra line in there. A minus 6a, right? So I could have grouped, and I didn't group in this case. And when you're solving your questions, you don't have to. But I'll write the line I'm missing. I would be satisfied if you wrote me a test and you went, I'd be thrilled if you did this and then this, okay? And even you wouldn't even have to show me this. I would know where you got it all, right? But this is the background so that I'm explaining to you. A line that I could have right in the middle here, but you wouldn't have to show me on a test, would say equals a minus 6a minus 3 plus 4. So I could throw that line right in there, okay? And that's why a, so that's like 1a minus 6a. 1 minus 6 is minus 5. The a just stays. Minus 3 plus 4 is plus 1. Okay? And that's how I got my final answer. That's a good one. That's a tough one. Brackets and brackets. Okay, these look hard. These look harder than they are. Okay? What do I mean by that? Well, first of all, square brackets. If you have brackets and brackets, so I've got brackets on the middle and brackets on the outside, all kinds of brackets. Usually you have your outer brackets are square. And what you do is you pretend, the first step of the equation, you write the 4 and you write the square brackets, but other than that, you just try to solve as much as you can inside the brackets. Right? You do everything you can on the inside, and then you worry about the outside brackets later. So let me just show you what I mean. So I left the square brackets. I left those outer brackets. I left the 4. For now, because let's think BEDMAS for a minute, I have to do this multiply before I can do any adding. Okay, so I left the 3x because it's added. And then I've got plus 5 times x is plus 5x. Plus 5 times minus 2 is minus 10. Right? Plus 5 minus 2 minus 10. I distributed the 5 through. I can get rid of the inside bracket, so I don't no longer have brackets and brackets. So I'll simplify in here. I can simplify by going 3 plus 5, so I get my 8x and minus 10 right there. And now I distribute the 4 through, right? So I multiply 4 times 8x. 4 times 8 is 32. And then 4 times negative 10, whoopsie, 4 times negative 10 is minus 40. Okay, that's a brackets and brackets example. And I got one more before we're done. Actually, then we have a word problem. Okay, so in this example, exact same problem really. I just put more negatives in it. So I keep my minus 3 on the outside, keep my square brackets, keep my 2, because so far I can't do anything with that. But then I do what I can, right? I do the inside. So I go minus 6 times a, so minus 6a. Minus 6 times plus 1 is minus 6, right? So I'm just distributing the 6 to here and the 6 to here to get this term. Now I collect everything I can inside. 2 take away 6 is negative 4. And then I still have minus 6a. Remember that minus is that one there. And this is minus 4 because I'm going 2 subtract 6, which is negative 4. Now I distribute the minus 3 through. So it works out to minus 3 times minus 4 is positive 12. And minus 3 times minus 6a is positive 18a. And then just because we usually do write things with the variable first, I just switched it. So remember, those are the exact same statement, just written in the opposite order. This isn't that big a deal, but it's a communication thing. Okay? All right. This is a long one. I got one more example, and this is a word problem. So we got Ferd, and he works as a furnace repairman where he charges $40 just to show up at your house to fix your furnace, and then he charges $10 an hour after that, which is a great deal. So it says, write an expression to represent Ferd's charges for a visit. And we start that by making a let there, let statement, right? So let H be the number of hours that Ferd is working. I chose H because it's sort of representative, H for hours. And so the expression is the money he charges is 40. It's 40 no matter what. If he shows up and he comes and goes, he knocks on the door and leaves, you owe him $40. Okay, plus $10 for every hour that he's there. So $10 per hour, which means you multiply it. Okay, which kind of makes sense. If he's there for 2 hours, you got to pay him $20 for the 2 hours plus 40, so $60. Okay. Part B says, okay, so what if he works on your house for 3 hours? How much do you owe? Well, you say I'm going to use grass to do this. I'm going to say G, his H is 3. Second H was sort of unnecessary. We're looking for how much money he charges. So I'm going to apply this formula. I'm going to substitute in 3 for H. That's all this is. Just instead of writing H, I'm writing 3. So it's 40 plus 30, which is $70, which again, if you think about it, he charges $10 an hour, so that's $30 plus the 40 to show up, 70. I mean, that's the math. That's how you think it through. Okay, so my final state the solution, therefore Ferd charges $70 for a 3-hour visit. Now, double time. There's an easy way you could do this. You could just say, it's going to be it's $70 for 3 hours on a regular day. I know you're smart enough just to know, okay, it must be $140 for double time. And that's fine. But I just want to show you how we would apply distributive, why this question counts it as a distributive property type problem. Another example where creative solutions, one answer. Okay, so if your instinct to say double, so 140, obviously that's true. Here's the distributive property reason why. Because it's double time, my new formula I would apply is 2 times the original formula for, this is how much I said is for 1 hour or for regular time. Well, now we're doubling it, so multiply by 2, right? So same thing. Hours is 3. I'm looking for dollars. This is my new formula, right? Substitute in and solve. So I go 40 plus 10 times 3. And, if I was going to use distributive property, I could go 2 times 40 plus 2 times 30. But it works out to $140. So that's an example, word problem type problem you might see later on. But anyways, please make some notes if you have some questions for me. That was a long one. That was the longest of the year. Sorry for that. See you tomorrow.